Hello everyone, and welcome to Network Labs. Today in this video, I will show how to configure BGP AS path filter and local preference to control the outbound or request traffic. In the previous video, we have configure AS path, pretending to influence the inbound or download traffic. Here the route map matching the customer's prefixes and set with AS path prepend value is applied outbound to the desired eBGP neighbor. Now we'll optimize the outbound traffic of the customer. By default, the best path to reach the Internet routes is via ISP1, since the next hop IP is lower than in ISP2. For our task, all customers' traffic must use ISP2 as primary path. To achieve this, we will configure local preference and apply inbound to the eBGP peer-facing ISP2. Use 300 for the value of local preference. Going back to BGP attributes in our service provider lab, higher local preference is preferred with a default value of 100. In the previous videos of this series, basic BGP has been configured and AS path prepending to influence the inbound traffic of the customer. Now let us begin the configuration. Here, the configuration is straightforward. Create a route map for both ipv4 and ipv6, then set the local preference. After creating a route map for ipv4, create new route map for ipv6 with the same local preference value. Enter BGP configuration and apply the route map under each address, family inbound facing ISP2. Exit from ipv4 address family, then enter ipv6 address family. Apply the route map created for ipv6 facing ISP2. That is all for the configuration. Reset the BGP connections and check the updated BGP routing table. After all the BGP connections are re-established, we can see that the updated best path to the Internet is now via ISP2, as desired for both IPv4 and IPv6. This is due to the updated and higher local preference value that is applied. To complete this task, let us go and conduct a tracer route to the Internet routes for both IPv4 and IPv6 in PC1 and PC2. In PC1, the updated path is now via ISP2. Similar results in PC2 for both IPv4 and IPv6. In addition, make sure that if ISP2 fails, the traffic should traverse via ISP1. Shut down the interface facing ISP2 and check if the failover will work. The updated BGP routing table now chooses the path via ISP1. With this, we are done with basic BGP local preference to influence the outbound traffic. For our last task, Internet 1's route should be reached via ISP1. To achieve this, we will configure AS path filtering by using a regular expression and apply a local preference facing ISP1. Use 350 for the local preference value. While underscore followed by AS number 11, then a $sign for the regular expression. This matches prefixes that originated in AS 11. Internet's traffic retains via ISP2. If the link to ISP1 fails, it will divert via ISP2. In the border router, the best path to reach both the Internet routes is via ISP2, since we have applied a higher local preference to the eBGP peering. Now, we will apply a local preference facing ISP1 using AS path filtering. First, configure an AS path access list permitting the AS number of Internet 1. Next, create a route map matching the access list. Under the route map, apply a local preference. Make sure to create the same route map with higher sequence number to allow other prefixes. Next, under the address Family in BGP, apply the route map facing ISP1. Clear BGP connections for an updated BGP routing table. In the updated routing table, the best path to Internet 1 is now via ISP1 with a higher local preference value. And the best path to Internet is still via ISP2. Shut down the link facing ISP1 to test the failover. All the traffic diverted to ISP2 as desired. With this, our task is successful. In this lab, we have successfully influenced the customer's outbound traffic using local preference and AS path filtering using a regular expression. I hope that this is informative to you, and thank you for watching.